So I apologize in advance for constantly going like this and having to constantly move things between two screens because for tons of technical reasons and because Google's a horrible, horrible code writer, all of my demo code can only be compiled on Linux, and insert every joke ever about presenting on Linux. So pretty much the origin of all of this research isn't mine, and I wanted to give credit to my coworker who was kind of the birth of all this stuff. Kind of the story of where this talk came from. This talk is kind of a redux of some of the work that we released at Black Hat and the Packet Village at DEF CON, only at those two venues we had some stuff that we couldn't say because Google yelled at us, and then we had the Black Hat talk was obviously more geared towards kind of a corporate audience, so we had to skip over a lot of the technical details just because there's so much stuff. But basically, about a year and a half ago, maybe 2 years ago, she did some research on MPTCP, or multi-path TCP, which, like super compressed explanation, TCP handshake, right? Syn ACK, syn ACK. Okay, well in multipath it's syn, and then ACK has a little cookie attached to it in the sequence header that says also accept stuff from this IP, and then vice versa. So you build these kind of clouds of IP addresses that talk to each other, and that is what's used in Siri. That's how Siri talks back to Apple. It's also how some other companies that shall remain nameless are getting around the Great Wall of China, because without TCP sessions, all of their monitoring tools tend to not work. Or not block, which is more important. So I said all that to say this. Basically, Apple built it first, Google built it better, and this talk came around by her looking at the QUIC stuff that Google was doing based on all her previous MPTCP research, and she sent me a message one day at work and said, "Hey, I think I've got this talk idea, but I don't write, weaponized code. Can you build me a weapon out of this?" And I was like, "Yeah, okay, give me a minute," because that's pretty much all I do. And I got it to work, so then she sent it to Black Hat, and she was like, "Well, you wrote the demo, so now you're in the talk." So she's not here, I'm here, I'm doing it by myself. Just want to make sure that credit was due. So this, there we go. Where'd it go? I'm gonna find my video now. So this talk is, I'm not dropping any like massive creative exploits or anything like that. It's really more of just an overview of something that's already everywhere, but a lot of people don't know that it's everywhere, and that's kind of what makes it relevant. So to introduce the scope of what I'm talking about, I'm just gonna let this video play. Kate made this video. Originally, she had this whole spiel and she told this whole story about coming to DEF CON for the first time and researching the trip and browsing the internet. But the main takeaway from this is just to notice that there is nothing weird visibly about this screen video of somebody using a computer, other than the fact that all the websites they're visiting are Google websites and that it's a Chrome browser, which I will explain immediately once we get to the juice. So using Gmail, using Google Maps, using YouTube, playing videos, getting location services, clicking around. Nothing super amazing. Because why not, right? So the thing unique about how this video was made is that TCP is completely turned off, in and out, yet everything works. So that's what this talk is about. The reason this works is because Google has rolled out a new protocol called QUIC, or QUIC Internet Control. QUIC UDP Internet Control. And it is already in, sorry. It is already in every instance of Chrome on the planet. So every single device in this room, if it has Chrome installed on it, then you have QUIC enabled unless you've manually turned it off. It is entirely UDP based, it's bidirectional, it's multiplexing, and we're going to totally get into the weeds right now about how it works. But the ultimate takeaway from this presentation is that it's already everywhere and nothing knows that it exists, so pretty much zero of your security tools even speak it. This is about as close as you can get to seeing it on the wire. This is what Wireshark looks like when it's taking it apart. Fun fact, all these extra pieces of metadata about the packet traffic only work when you tell Wireshark in advance that you're looking at QUIC traffic. If you move the port for any reason off of 80 or 443, it just goes, I don't know. So this is what it looks like under the hood. So QUIC is actually a wrapper for HTTP2. We're going to get into HTTP2 in a minute. But essentially, HTTP2 is made of frames as opposed to H1, which is a TCP socket connection, and you send like a blob of text, and you essentially get a blob of text back. H2 is this binary protocol where it's this back and forth frame dance, and UDP is essentially, instead of that happening over a TCP direct socket, it's all happening as encapsulated UDP packets that can be individually routed. So you can change IPs, you can change sessions, you can do all kinds of crazy things in terms of the transport layer, and they won't affect your traffic. But after you take things apart, and if you dig deep enough, there are some things that look familiar. I'm going to skip through these kind of fast. A lot of these slides are left, or pretty much this whole slide deck is made out of my Black Hat slide deck. The takeaway here is that adoption, right? Like HT was a thing. The precursor to HTTP2 was something called SPDY, or SPDY. That took a while to get rolled out. Basically, I'm skipping a whole lot of detail on the development of how these protocols came to be, because there's a lot of third-party organizations and companies involved and things that they tried to push. There's one slide I'm looking for. Like I said earlier, the MPTCP was kind of the early adoption of a lot of this stuff, and then, Google was like, how can we do it better? And I said, well, we can do the same. We can do all the multiplexing stuff that they're doing, but use UDP instead of TCP. But that was kind of the evolution, right? And by their powers combined, we have the current implementation, and nothing knows how to take it apart. So this is kind of the slide I wanted to get to. This is kind of a big deal when you look at the amount of time that this was deployed over. It took Apple a long time, generally speaking, to get MPTCP pulled out, even though they were putting it on all of their devices, or on all their mobile devices, when they wanted to push it as an inception. And even once it was implemented, even though it was implemented in protocols that they mandated, it still took them several years to get 50,000 or 100,000. Once they got to hundreds of thousands of clients. QUIC moved a lot faster, like a whole lot faster. In fact, it even moved, if we look at it from a ratio perspective, it even moved faster than HTTP2, which is saying something that HTTP2 came first. The only reason I'm kind of harping on this is because it's one thing when new protocols come out and it takes them 10 years to get involved, and our security tools don't speak it for 12, because that basically means we have 10 years to write our own stuff and be better than everybody else. When one company can push a protocol and it's in everybody's stuff in a year, that means if you didn't write it and push it into your product last year, you're just fucked, like from the get-go. Yeah, these are the top, I think it's the top 15 or top 20 HTTP2 supporting sites. So these sites already speak H2 even without QUIC. If you just start talking to them, they totally work. Why is, okay, feature number one of QUIC, right? Multiplexing. So normally, when you set up a socket to do stuff, to send traffic, you have a socket, and that socket is context, and over that context, you transmit data, all right? Except data is actually made of packets, we all know that, but the packets still travel in the same context. There's still one single flow of understanding on how things work. Multiplexing is when you mix them all together. QUIC multiplexes by, first of all, the entire routing stack is implemented in user space. The whole thing's UDP. You don't need a socket to drop to system level to start sending things. And all of the context for all the data is handled at the application protocol layer. So you can send packets. I mean, I have some demo code in here, which I don't know. I'll do if we get time for it, but it's a little weird to look at because I don't have a pretty way to kind of show why it's enhanced. But basically, I can take a HTTP QUIC session and send every single packet from a different IP to a different IP and route them all to the same servers on the other end, and the client has no idea that anything's changed. And that's because multiplexing is happening under the hood. The concept of a session is a programming concept, not a literal one. Yeah, and this is technically not true because the only implementation that's out there right now is Google's, and they actually have a hard limit on connections. I don't remember what it is. I think it's something like 100 per stream, but it's still arbitrary. You can change that number in the C and everything works. So to really understand QUIC, you need to understand HTTP2. So this is kind of a weed dive on H2. So H2, as opposed to H1, right? H1, you have your TLS session, you have your SSL handshake negotiation, you set up a TLS socket, and then you send a request, you get data back. Or with H1, sorry. With H2, you set up a TLS socket, but then you send these frames. And these frames have different types, they have different orders, they all do different things. And one of the things we'll get to, depending on how many demos I end up running through until I run out of time, is that I showed you that slide earlier with the top 15 HTTP2 supporting websites. We are already starting to see deviation in how people implement the standard on which frames come where, which even if you ignore the implicit security fear that is wrapping a binary protocol and then another binary protocol and parsing, dear God, it means that fingerprinting is essentially trivial. Like we're already seeing getting to the point where if I send a settings frame and then a ping frame in that order to Yahoo, and then I double it, and I send the same frame category to Google.com, I get a slightly different response, or I get a slightly different frame order back. So just on alone means that you can fingerprint web servers, which is obviously a security risk because it means that full implementation of information security is impossible. So this is kind of a medium level overview of what frames look like in H2. We might get into the frame pieces later on, but the important thing to remember is that in H2, pieces of data exist inside frames. The frames themselves are just overlying containers. But the fields, like each field, you can have multiple fields inside one frame of H2, which is just important for multiplexing reasons. So yeah, you have one stream, like you have one connection. In that connection, you have streams. In those streams, you have frames, and the frames move in two directions, and these move on infinitum. For QUIC, I'm going to get to some other slides that explain what QUIC looks like a little better. But essentially, this is really the only documentation out there on how the encapsulating part of the packet is defined. And word to the rise for anybody writing fuzzers, all the lengths and all of the encapsulating data are variable. Insert joke. So with QUIC, you have one H2 frame per QUIC packet, and there's one negotiation. Like the first packet that you send has mandatory TLS in it, and it is the first part of your handshake. So it is totally impossible, at least by spec, to use QUIC without encryption. Now, considering the fact that HTTP2 by default also mandates encryption, I don't know, maybe we're starting to win the battle on this security thing. It's a little bit of overhead, and there's a lot of, and I haven't seen an implementation of H2 yet that doesn't also support H2C, which among very specific tweaks is basically HTTP2 without mandatory SSL, but QUIC fixes that problem. So with QUIC, you get your QUIC packet. Your QUIC packet contains an H frame, and then the H frame contains your field data, and your field data is how data is processed. This slide looked a lot better at Black Hat because I could actually run PowerPoint on my laptop. I can't on Linux, so you just get the static Piction version. But basically, the animation that's missing is this looks like a layer cake, and it's actually not. It's like, think of it like a Russian Markosa doll, right? So like the UDP packet is on top, and then the public header is a field inside the UDP packet, and then the AEH data is another field inside that same packet, and then the private header is this block of hex, and then inside this block of hex are QUIC frames, and inside those QUIC frames are H2 frames, and inside the H2 frames are fields, like we talked about earlier. So what can we do with it? Anything you can do with a proxy that, anytime you can do a scary thing with a proxy that has a security concern, this does it better. It's faster, it's more resilient. There is documented support, although not implemented yet, for error correction, which, while being a feature, is actually super scary if you can do things like bit flips randomly in standard traffic and expect the parser to understand it on the other end, because that means there's no difference between arbitrary traffic and fuzzing. The multiplexing we've already talked about. I've already mentioned that pretty much no security tool is really taking these things apart on a wide level. Pretty much just generic, proxy scariness. What slide is this? Is this the wrong slide? Huh, I moved that slide up too early. Anyway, all right, so now I'm going to do a demo. So this demo is, there's pretty much two functioning implementations of QUIC on the internet right now that I'm aware of. Chrome, the Chrome client, and the library that runs under the hood in the Chrome client, which is open source, and Google's Golang breakout of that C source, which is terrible, by the way. Like, you'd think the company that invented the language would write the language decent, but and a native Go breakout, which is totally not ready for prime time, but has a lot of promise. Long story short, because Google's source is so bad and fucking unwieldy and statically hooked up to its own brand of boring SSL that you can't rip out or do anything to, it's totally impossible for me to take the parts out of it and compile it on multiple operating systems or use in something like a interpreter transport. I'm most of the way through a interpreter transport, and if my RSA talk gets accepted, I'll drop it there. But in the meantime, this demo is essentially a tube. So I have a server on one end, written in Go, running an HTTP1 server. It accepts an HTTP call. The HTTP call is then translated into a QUIC request. That QUIC request is sent through the internet, but in this case, I'm doing everything on a LAN, to the second binary. The second binary is a QUIC server, which is Google's implemented code, because they just built a client and a server. It accepts that QUIC, turns it back into H1, and then sends it someplace. The idea being that this nexus point is the thing that nothing understands yet, and this is what you can use to evade every anti-scary security thing in the world. So my demo of doing this is we are going to psexec a Metasploit payload over QUIC. Bear with me, I gotta move a lot of stuff to that screen, so it's gonna get weird. All right, that's the video. I don't need the video anymore. Okay, so first our victim. This is our victim. It is a Windows 7, the IE8 test image from Edge. That is its IP address, standard username and password. The only tweaks I made to it is going into the registry and manually enabling the local user to have access to the admin share over SMB, because Microsoft now turns that off by default for security reasons, unless you're running on a domain. But other than that, it's a stock image. There's no weird voodoo. Where's my mouse? Okay. So this is our Metasploit instance, which is running a bunch of listeners. And I'm just using a standard reverse HTTP interpreter port with our psexec information filled in and the psexec exploit. I have the auto start listener feature deactivated, obviously, because we're not going to use the default listener. We're going to use our tube, which is instantiated. So this is the first half. This is the H1 to QUIC binary. And I think, yeah, so you can see up there the usage that I put into the tool. All this code is open source, by the way. I'll totally drop all the GitHub links. And the slides that are on the Black Hat version, which are public also on the Black Hat website, have the links to the third-party repos that I pulled the libraries from. So if anybody gets curious, you can point and click your way to victory. Anyway, this is the first half of the tube, and we see we're dialing back, which means, you know, where do we want our QUIC packets to go? We want those to go to port 8081, and our default listener is running on the public interface. That's actually my VM interface on 8888. Is that the right one? Oh, next one. And then this is the other half of the tube, which is more or less the same arguments, except it is back proxying to our interpreter, or our Metasploit instance over port 80. And it has SSL keys added to it. The reason it has SSL keys added to it is because, as I said earlier, it is impossible to use QUIC without using HTTPS. Also, their implementation makes it impossible to use this without signing keys. It can be done, but the only way to do it is to basically you have to go into the function that does the key management and nop it out. And that's actually significantly difficult to do in the library as it's written currently, because the way that Google wrote their Go abstraction for QUIC is that they use CGO. So if you know anything about Go, you know you can call C under the hood. Well, they basically took their C library and then did all the SSL stuff in C and then made that a function call and have Go call it. So you've got to call that function super, super special to make it not do SSL things. It's a giant pain in the ass. And then over here, I'm just going to start a Wireshark instance, so that way, after we hit go, you can see what the packets look like. All right, packets. So now we're going to go to Metasploit, and come on, demo gods. So here's our PS exec. And there's our shell. So if we want to see what the shell looks like, we can stop sniffing packets. And we see at some point, we just start saying a whole bunch of UDP over 8081, and Wireshark has no fucking idea what it is. And even if I tell it manually, let's see, I remember where the stupid option is. Decode as UDP port. There's a search field that I can't read because I'm reading upside down. Anybody see where QUIC is? It's in here somewhere. I just can't find it. Oh. Where? Oh, thank you. You can tell how often I use Wireshark. There we go. All right. Even if I tell it it's QUIC, even though that it can see the SSL handshake, that's pretty much it. It doesn't really know fuck all about anything. And this is the most feature complete, or it was the most feature complete QUIC parser that I'm aware of with sensing until my passive demo. And the only difference is that I actually check the 8-byte checksum at the front, which I'm pretty sure makes my stupid 4-line sniffer the most accurate QUIC detector in the world. Yay me. All right. Huh, made it back. Awesome. All right, so that's today. In the future, this gets a lot scarier. So potential exploits. First of all, at Black Hat, there was there was a group of researchers from Imperva who actually dropped an H2 bug, and I'm only bringing them up to say that H2 has already started becoming a target for browser fuzzing. There have been some bugs in Chrome that are patched. There have been some bugs in pretty much every browser that have been patched over the last year or so that are starting to come out. There's a Go-based HTTP2 fuzzer that I can't remember and was going to put it in the slide, but I didn't. But if you go to GitHub and you look for HTTP2 fuzzer, it's pretty much the first one that comes up. That's very, very, very feature complete. It's not being supported anymore, but I mean, if you're looking to harden things against H2, it's still probably the best thing that I've seen without having to muck around in something super low level like Peach. And Chrome's pretty resilient against it. Firefox is pretty resilient against it. Safari is not. I haven't seen a whole lot of successful exploits against Safari, but it does crash a shit ton. There's nothing for QUIC, so yay bugs. Also, I don't have a good de facto example to give you, but let's just say that the QUIC wrapper is so simple that polyglots are inevitable. For example, if you were to look at the beginning of the QUIC header with the HTTP flags removed, and to just have the variable size part of the protocol as like your own type of grammar, there's functionally no mathematical difference between that and a VoIP packet. So anything that's doing VoIP parsing that isn't parsing it all the way down to every little bit, I guarantee you is going to start saying QUIC if you start telling it, oh yeah, I'm running VoIP on port 80, see what happens. Yeah, problems exist. Yeah, pretty much just polyglots and multiplexing, and then you can mix the things together, right? So we have our multiple connections, right? We have our packets going on the wire that are like one IP address to one connection type. We multiplex them into a single connection, and then I can take that connection and I can remultiplex that, because now I have a new linguistic context. This gets real hairy because technically I can implement those last two slides forever. So yeah, the future is a scary thing. Right now, in terms of analyzing and defending and doing all that blue team stuff, when I gave this talk the first time, the rule from my employer, if anybody asked, well, you work for Cisco, so. And the sentence I was supposed to give was, I do not work in product, but my product team is aware of it. You can ask them any questions. Now that talk is over, I can be a little bit more candid and tell you that actually product is super aware of this. There already is defense in pretty much anything newer than like a Fire, whatever model number it is, 4700. It's not a particularly elegant defense, but basically all UDP that they don't know about other than DNS is explicitly disabled by default. And anything that it senses as H2, it basically just back proxies to H1, which is a relatively well enough understood process that you're not really going to break anything. But obviously, that's a Band-Aid. I've actually seen code in some of the latest patches that are coming out to fix some of the double bacon hacks that they're already starting to. I'm assigned to the team that is actively fixing these things at this point. So you're already technically safe because of downgrading, but explicit support is already in some things and getting more active. I'm trying to remember why. Oh, now I remember. So this ALPN thing, part of the reason why implementing some of this stuff is still so weird is because the only implementation out there is Google's, and they're still changing stuff. Like every once, like this ALPN thing used to be like an option, right? It was like part of the crypto. You could turn the flag on, you could turn the flag off. It didn't really care. Now it's mandatory, but only in the client. If you don't use it and you talk to YouTube, it doesn't care. If you don't use it and you talk to Gmail, it ends your session. It's fucking weird. Anyway, they're still changing it, and so that means that forks and independent implementations are dangerous because you don't know when whatever feature set that you implement is just going to go away. H2, on the other hand, a lot more stuff speaks. Yes, you can curl H2. It's kind of funny. QUIC, Chrome is really the only thing that speaks it with any real negotiation. Everything else is, if you tell it to analyze it, it'll kind of give you some metadata, but it won't really take it apart very well. I don't remember why this slide is there. Sorry. Oh, that's right. These are all the examples of all the things I just listed. Time attacks and stuff. These are headers in H2. Anyway, these things aren't really relevant. This is all stuff from the Black Hat talk, trying to convince business people to care about it. This is a cool screen, though. If you want to turn QUIC off, or if you want to know if you have QUIC turned off, that's where you go. Just type that URL into Chrome, turn it, do your thing. LPN, analyzing, defending. Where did these slides come from? Yeah. So I've pretty much said the first three things already, but the last conclusion to make light of is, like I said, I'm pretty much 70%, 60%-ish of the way through writing a full drop-in for Meterpreter speaking QUIC, which instantly means everything's not going to find it, and that's Meterpreter. That's the implant we know about. So the implants are coming. Funny story, actually, after we gave this talk at Black Hat, immediately after I get off stage, some old guy who walks up says, well, thanks, but your talk kind of bummed me out. And I was like, why? And he's like, well, I work for an agency that should remain nameless, and I've been using QUIC for pen tests for 4 years. Now I got to find something else. So apparently it works. Totally works in the field. And actually, I do have a couple of implants, which I'm not going to share, that are very rudimentary right now, but I've been starting to feed QUIC even in the current library implementations into it, and yeah, it makes your binaries bigger because you have to use Google's code, but nothing sees it, and it doesn't flag as malicious, and it's really easy to start doing multiplexing and polyglots. Any questions? Yeah, pick an email address, or you can hit Kate up on Twitter. She is totally down to talk about stuff. Yeah.
Thanks. I don't know. It's amazing how fast they roll out QUIC. But do you think that other people will start using QUIC more?
Absolutely.
Even though Google is going to change anything.
Well, so Google, when they came out at Google I/O this year, that was the first time they really called attention to it with a product. So Google's new Duo video chat app actually is QUIC-based, because that's why QUIC was invented. It's actually, aside from all the really scary security things about binary parsers, it's actually pretty cool. It's fast. It's fast in the same way that MPTCP is fast, but it routes easier because it doesn't have the TCP overhead. It basically was designed for bidirectional video chat. That's really what it was. It's the reason why, if you are on a box that is large enough to cache video data in whatever codec that Google is using, that YouTube tends to suck less now than it has in the past few years. But phones have smaller caches, and also they still use crappy video codecs. So one problem at a time.
But are there other implementations of it than the Google's implementation?
Well, the implementation that's in the Chrome client is open source. It's a C library. You can just go download it. So, technically, yeah, it should be in anything that anybody wants to use it. I don't know what the plans are in terms of explicitly pushing it as a protocol, but I can't imagine they wouldn't. They wouldn't have built it, and they wouldn't be using it on YouTube if they had any other plan.
Yeah, but they could potentially figure it out. Or maybe they want to make a big change in it. If they roll things out this quickly,
oh yeah,
then everybody has to change their implementation of it.
This is true.
As quickly.
This is true. So clearly, we should all just write implants faster.
Awesome. How many people are using this already in pen testing stuff? Oh, really?
I'm the only one?
Really? But that means you get questions and microphones. I saw one hand there somewhere and one hand here.
So my question is about encryption on QUIC. Originally HTTP2 was going to be encrypted traffic only,
yes,
like SPEDI. Then there was this political mess up, so they passed, as you said, HTTP2C,
right,
which allows unencrypted connections. Do you think there will be unencrypted QUIC happening at any point of time?
I I doubt it. I'm pretty sure QUIC is going to stay encrypted the whole time because the way, if you look at the spec, the way the QUIC packets look, the negotiation process is built into the order of the packets. Like literally the first packet has a TLS signature on it. And if it's not there, like there are parts of the spec as it is right now that just don't work logically. So it would be more work than just remove, like it's not like removing it, oh, I got lazy so we just didn't implement crypto. It's like not implementing crypto actually makes it harder to use whatever existing package is out there.
So this is the first time I've heard of QUIC, so this might be something you already answered, but is QUIC something that only Google will use and you have to basically reverse engineer the library or the traffic?
Nope.
Or is it slated for a standard of some sort?
All the source is public and the wire diagram thing, and let me go back to that slide. So many slides. The draft, Hamilton, shade, mapping, linear. I think it's this one, but if not, if you go to the first one, the first link, there's a link to a Google Doc called a wiring diagram, and what it actually is their RFC, and it explains, there's a full breakout of, at the bit level, every packet, and you can do it manually. There's already some people who are doing it manually.
Okay.
Okay. Is this implemented on all the Google sites, or is it implemented on the Google Cloud platform?
I haven't looked at Google Cloud. I assume it is, but I mean, yeah, it's on Google.com, it's on Gmail, it's on YouTube, it's on everything. Like I'm pretty sure it's just their front-end web server.
Hannah? One question in front.
Great talk. So what do you think is the lag time for DPI providers to implement QUIC monitoring? Like, I mean, it's still TLS at the bottom, so they're not going to be able to see the content. But
QUIC monitoring without the H2 introspection? Pretty quick. I mean, I kind of cheated because I had a bunch of code lying around for building packet sniffers already for pen testy stuff, but provided that you have that, and there are other people who have that, the protocol itself is not complicated. I mean, it's maybe there's 4 types of, there's like 4 packet types and like 2 frame types. Really the issue is that right now the only implementation of QUIC that exists, which is all of Google stuff, is like hermetically tied to HTTP2, which is order of magnitude more complicated. Not because the packets are hard to understand, but well, the frames are hard to understand, but because there's like 15 frames and the order is non-determinate. You can get any frame at any time, so you get giant case statements, and the least determinate your case statement, the worse your code is.
When you give this talk, do you see that a lot of people don't know about this? That a lot of people just have no clue.
Nobody has any idea. I mean, that was pretty much, like, I'm pretty sure the only reason this got into Black Hat is because we got to tell people that, hey, this is 6% of the internet and none of you speak it. And they all went, what?
Do you know if there are any Apache HTTPD implementations or Nginx coming?
For QUIC?
Yeah.
There are none that I'm aware of. There's H2, there are no QUIC.
And that's actually my question as well. I mean, there is, Nginx have had H2 for a couple of years, people are turning it on and actually finding that, yes, it reduces load time, it works better. So do you think this will be, H2 and QUIC will actually be the standard going forward from HTTP 1?
Maybe. I mean, it depends on it really depends on what Google does, on if they decide to do what Apple did and they turn this into, hey, we invented this thing that we open source, but we're not really going to do any work about making the open source stuff easy to implement, and our stuff works better, so you should use our stuff, or whether or not they actually start involving members of either the IT security community or the development community, or hopefully both, and start actually growing the protocol. Because I think they could, and I think they should. I mean, I think it solves a lot of problems, but ultimately that's a business decision, and I don't work for Google, so.
So are there any thoughts on how to do QoS and other types of things on this?
I would be very afraid of doing QoS on this. I will say that you can do QoS on priority frames on H2, and it breaks things. there are websites that just stop talking to you because they go, I don't know where this priority frame goes. Never mind.
I saw a hand over there as well. Let's see who's faster with the microphone. Peter.
It will be in stereo. I did some Googling, and it's some caddy server that has experimental code for QUIC.
Oh, yeah. I haven't seen it, though.
Yeah. And Daniel Stenberg, working with curl and at Mozilla, is also working on it, so curl will probably support it soon.
I would assume so. We actually got contacted by the guy or like the people that were maintaining curl after we gave the talk. But, I mean, I don't know. Curl's more of a utility than a backend. Yeah, also. All done?
Do we have
one more? Yay.
Run.
Nope.
In your experience, what are the chances that using QUIC for pentesting will actually work to bypass a firewall?
Using QUIC to, I'm sorry.
Using QUIC, for example, as you did, to start a meterpreter session and multiplex the data through the QUIC protocol, what do you think are the chances that it will actually work on a standard?
Oh, in like malware?
Standard? You can say malware, you can say pentest, yeah.
Well, I mean, me. But there's at least one actor doing it. I don't know who, anything, whatever, but yeah, there's at least, I have one sample that was given to me in confidence by a friend at a very large tech group that will still remain nameless, that wasn't doing anything particularly harmful. It was just like a dropper wrapper for whatever they were doing. But it didn't speak QUIC exactly, but it made UDP packets over DNS that specifically looked, the checksum specifically looked like QUIC. And I have a feeling that they were doing that to beat DNS check centers because other tends to fail open, but I don't have proof or evidence that that's actually what was happening. But yeah, I mean, I have implants that run QUIC right now, and it's incredibly effective. And it's also, like I can do MPTCP style things where I can launch a shell that I don't talk to for 30 minutes and then talk to it on a completely different IP, and the session is still there, crypto and everything. So, I mean, if I can do it, I assume somebody else is doing it. And that is with this horrible, horrible, horrible fucking Golang exfil crap that Google put on the internet. So it's only going to get easier. Yeah. I don't have a problem dissing them about that because I was talking about that at Black Hat and some guy who was sitting in the back, I was like, you work for Google, don't you? And he stood up, kept laughing, and left the room. I was like, yeah, fuck you guys. Fuckers. Could have just written it in native Go, but no.
Is there any form of source address spoofing protection in QUIC?
No, because it's not relevant, because IP addresses are just methods of transport to your connection, and your connection is tracked in software, and TLS is mandatory, so a signature is included.
Is that it? Other questions? In that case, I think that we should consider ourselves informed of QUIC. Thank you very much. Vyrus.
Thank you.